Okay, welcome to Chapter 25 in the Practices book. Chapter 25 is on Data Center Overview, page 449. So before we get started, let's just talk in general about, let's say I'm a big company, I want to build a data center. So what do I need to do? Well, power and cooling are the two number one things, the two most important things it takes for figuring out where you're going to put your data center. You need a lot of electrical power. And you could be a big company like Microsoft and you could go into an area that flat doesn't have a utility grid that can support it. And there's not much you can do, even if you're a big company. Okay, so electrical grid is kind of important. And the second is cooling. I mean, if you're doing this all with just traditional, air conditioning kind of thing, you're going to need even more electrical power. But wouldn't it be kind of cool if you had a lake or a river or an ocean or something that could help you with your cooling needs? That would be pretty doggone cool. So, not surprising, data centers are located in those places where electricity is cheap and cooling is available somehow. So, again, I can increase the bandwidth. Like if I'm trying to develop an area and put a data center there, I can spend money and make the bandwidth go up. But I really can't do anything much about cooling and power. That's kind of outside of my control. There's a really cool video here. I'm not going to watch the whole thing, but it talks about Microsoft had a demonstration project where they actually put computers in their data center underwater. Yeah, so let's just watch a tiny bit of this.
The overarching goal of Project Natick is to evaluate the feasibility of underwater data centers. Phase 1 was just to be able to figure out, can we get computers into a container and can we deploy them in the water without it leaking, and do the computers survive and how well do they last? Phase 2 was to show that we can make it in a manufacturable production scale component. So the container behind me, it fits on a trailer, it fits on a cargo ship, and it allows us to actually build up this data center to any size that we want.
Orkney is a great place for this partnership because they've got renewable energy for 100% and more of their grid power.
Computers are not designed to work in the environment that we humans operate. So things like oxygen, moisture in the air, that is really bad for computers. It causes corrosion on the components. You also get temperature fluctuations. So the heat from night to day and summer to winter can cause those components to fail. And so we had this theory that if we're in a really stable environment, we're in this cylinder, we've taken all the oxygen out, we've controlled the humidity, no one's walking around, there's nobody bumping things or causing any additional failures, that we'd see better reliability. And so far as we've been monitoring this and...
Okay, that's actually a pretty cool idea. The idea is that they went to an area that had, a carbon neutral power, and they sunk it down into the ocean where the temperatures stay essentially the same year round. Okay, and that's how they do cooling. Okay, so back to the book. So the types of data centers, basically based upon their location. A data center is a purpose-built facility just for doing that, right? Okay. Co-location, sometimes just abbreviated colo. Colo is where someone else has built the data center and I'm just renting, so to speak, a chunk of it. Okay. A computer room, well, that's a server room. You got a big building and you have a dedicated space just for you doing your computers. It has redundant power and redundant cooling and all the things it needs. But it's it's just for you and it's just for your building. A computer closet, okay. We kind of sort of talked about, it could be shared space in a building, where, you maybe that's where the hot water heater is and the air conditioning system is, but over in the corner is also where the computer is. By the way, that's not a very good idea, but it could happen. And then like the telecom closet, you could have a room someplace where all the electrical wires come out. This is probably where we talked about that intermediate frame guy. Okay, remember that guy? That's where you probably have all the cables, like on a floor. All the cables would be terminated, and you have a patch panel, a switch, and then a fiber optic cable that went down to the server. Okay, you guys remember all that. Good. So, just like this guy was saying on the video, server rooms are not really designed for humans. In fact, you really want to go out of your way to prevent humans from going in there for any reason. The machines are not good for humans, and humans aren't good for the machines. Like the guy says, you know, human bodies put off heat, and quite frankly, they're dirty. I mean, unless you're wearing, you know, a bunny suit, you're gonna be bringing in, you know, dirt on your shoes and, you know, pollen and dandruff, and, you know, that's not what's good for a computer room, right? Okay, so don't try to make a server room and then have an area over here for like the system administrator to sit. That's a bad idea. You don't really want people going in and out of there. Okay, so on page 450, they start talking about, you know, do I build, rent, or outsource? So let's talk about building. So it's not normal for like an architect to know exactly how to do this. You went to a normal business architect and say, hey, I'm getting ready to build this office building. He's going, great, I've got plenty of examples of office buildings. I've been doing that for years. And I want a state-of-the-art server room. He's going to say, what? They're not the experts in this. You really need people who have designed server rooms for a living. Maybe that's your architect. Maybe it's not. But yeah, you need specialized skills. You need somebody who's expert in power, like calculating how much power and how to do redundant power, where to put the emergency generator, where to put the uninterrupted power supply. Ventilation, they need to understand, you know, how much cooling is going to go on and how much air is going to have to be passed back and forth. And then security, you know, how do I keep other people from getting in there, because this is a high secure area. So once again, a normal architect may not have the skills you need. So, you know, the big boys in the cloud space, you know, like Google, Amazon, Microsoft, you know, they build their own, and that's called vertical integration, which means I'm building it myself, I run it myself, and I use it myself. You know, just vertical integration. I'm not hiring out any piece of this. By the way, when building a data center, the amount of staff on board at one of these giant data centers is relatively small. In fact, the vast majority of it is the guard force. Oh, sure, there'll be a handful of technicians, you know, who actually are technical, but, you know, we're talking, you know, a dozen or so people in the entire room, in the entire complex. Yeah, okay. Okay, so renting. I want to rent some server space. So you can rent space at somebody else's facility. Most of the time, it's by rack. In other words, I'm renting rack space. By the way, there is actually a company called Rackspace Technologies. They're in San Antonio, and that's how they got started, was renting rack space. Okay, so typically it's the number of racks, not actually what you have in there, because they just kind of assume that, you know, the power and the cooling, you can put whatever you want in there. It's the cost per rack. They obviously take care of the power and the cooling and the security, right? That's what you're paying for. And then they're, you know, and they clearly don't want anybody else's business. So your rack basically is yours, and the rack next to it might be your competitor's, but there's like no connection between the two. So they kind of do that separation thing for you. Okay, so outsourcing. So outsourcing is just, you know, let somebody else do the whole thing. You know, I put things in the cloud and I just don't care. Infrastructure as a service, IaaS, you've probably heard these terms. That's one way of doing it, where I just go to the cloud and say, look, I need this many processing cores, this much memory, and leave me the heck alone. I'll do my own thing. I'll install my own software. I'll do all the upgrades. I'm the administrator. I'll decide if I want to reboot everything. It's just as if you had a real honest-to-God server room. It's just that it physically isn't there. And then, of course, there's this whole concept of no data center at all. If you do software as a service, and a lot of your applications are done over the web, you kind of sort of don't need anything. You can have everything in the cloud and not have anything on premises at all. I mean, you could. I'm not necessarily suggesting that's a viable option, but it is something that could be done. So, like Google Apps, okay? Let's just say that, I don't know, for some reason, a university says, we're going to get rid of Microsoft's desktop software. We're just going to use Google Apps, and everybody's just going to, you know, do their word processing using Google stuff and their spreadsheets and all that. That would be a viable option. And then, of course, the hybrid option, which is probably the one that makes the most sense. And that is, look, I've got half of this stuff is on premises and half of it is on cloud. Maybe bits and pieces are in a data center someplace. You know, just because one size doesn't fit all. I mean, that's just the bottom line. Okay, so when trying to build a data center, page 452, you got to ask yourself an awful lot of questions before you get started, like, what are the requirements of this thing? And again, an expert at this could come up with these things rather quickly. So it's a mixture of both business requirements and technical requirements. And one of the phrases we talk about when we have the system design course is that business needs come first. If there was a conflict between a technical requirement and a business requirement, the business requirements are going to win if it's a tie. Okay? All right. So what are the business requirements? First of all, how do you even get the business requirements? This is kind of technical. If quite literally, if you were to wander around asking, interviewing people, okay, we're getting ready to build this building and we're going to put in a server, how much capacity do you need and how much this and how much that? They're going to say, hell, I don't know. Come on, right? A lot of people just flat don't know. And besides, if you start asking questions about like availability, they're going to say, oh, wow, let me give you a story. Okay. Hypothetical story, but still a good story. So let's say you're building this application, okay? A database server, let's make it simple. And then the CEO, read some article somewhere that said 5 nines for availability, 99.999, okay? 5 nines, 999. Anyway, he comes to you and says, hey man, are we doing 5 nines availability on our new database server? And you go, well, no, we're not. And he goes, oh, I think we need to do that. And you go, okay, that means it's going to double its cost because that means I need 2 of everything. I need 2 electrical services, 2 servers, 2 tape backups, 2 UPSs, 2 air conditioning, 2 everything. He's going to say, whoa, I didn't mean that. I just wanted it to be high availability. You see my point? My point is you can't ask them what do you want high availability? They're going to say, yeah, I want high availability. Okay, maybe they do, maybe they don't. You just can't rely on interviews to get these kind of technical questions. Business questions you can get. Technical questions, not so much. So, availability. How much availability do you need from a business perspective? In other words, how long can you be down before it starts hurting your bottom line? That's the kind of question. Don't start the question with 5 nines or 4 nines. Start with, okay, you could be down for like 5 minutes in a year and that won't cause a problem. They go, yeah, well, how about 10 minutes in a year? How about 15? Trying to get them to tell you what's the pain point in you being down. Okay, business continuity is very similar. It's how long is it going to take to restore? So availability is how long can you be down for like maintenance. And business continuity is if there was a complete failure and we had to replace the server from scratch, how long could you be down? How much money are you willing to spend to make that transition from replacing a server to fully operational? What's that pain point for you? And then, of course, the budget. There's an operational budget piece. You have to hire staff. You have to pay the electric bill. And then, of course, there's the capital investment because you'll be buying an awful lot of expensive stuff. Change control. Are you going to be following the normal traditional upgrade path, like a 3-year replacement cycle, that kind of thing? And if so, you're going to put that into like your entire life cycle cost? And then there's an interesting comment here. It's kind of out of place because we're talking about designing a data center. But one of the things that change management can do for you is you could have a freeze period. What that means is like, let's say on the 15th of the month is when you run payroll. And so nobody makes any changes to anything on the 15th of the month. Okay? In other words, no patches, no changes in architecture. Just leave the system the heck alone for this period of time. Okay? A freeze point. That's a good thing. And then are you governed by some sort of regulation, like a HIPAA rule or that kind of thing? You kind of sort of need to know that in order to be able to adequately design your data center. Okay, we're coming up on the 15-minute mark.